Welcome to the Surfer 13 webinar on breaklines and faults. My name is Katie Yoder. I'm a member of the technical support team at Golden Software, and I'm here today to go over some questions about breaklines and faults and how to use them in Surfer. Specifically, the questions I'll be reviewing are: what are breaklines and faults, and why would I want to use them? How do I define a breakline or fault in Surfer? And how do I apply breaklines or faults to my grid? After the discussion of each topic, I will have time for a few questions. You can send your questions to the webinar host via the questions box on the webinar control panel. Type in your question and it will be sent to the webinar host, who will forward it to me. Please send in your questions, but if I don't get to it, I will follow up with an email after the webinar is completed. This webinar will also be recorded, so after the webinar is finished, if you missed anything or want to rewatch something, the video will be available to view on our website at www.goldensoftware.com. So let's begin. The first topic I'll cover today is what are breaklines and faults, and why would I want to use them? In geology, a fault is a fracture or discontinuity in the rocks of the Earth's crust. This is a physical barrier between stratigraphic layers. Similarly, in Surfer, faults are two-dimensional boundaries that serve as barriers to information when gridding. The fault line is defined in a BLN file using X and Y coordinates. During gridding, data on one side of a fault line does not directly affect interpolation of data on the other side of the line. Faults in Surfer can be used to represent any physical barrier, such as geological faults, walls of a building, or any other firm boundary in the area being mapped. Because they're not actually geological faults, there is not a way to specify the amount of throw or movement along the fault plane. All faults in Surfer are considered to be vertical. Breaklines are lines along which a sudden change in slope occurs. In Surfer, breaklines are linear features with known z values. The x, y, and z coordinates of the vertices for the breaklines are saved to a BLN file for use when gridding data. The z value of the breakline is taken into account when the data is gridded. Unlike faults, breaklines are not barriers to information, so data on both sides of the breakline can be used during data interpolation. Breaklines in Surfer can be used to represent the ridge of a hill or a mountain, the bottom of a riverbed, the base of a cliff, and many instances where a change of slope occurs. As you can see in the examples, breaklines and faults can have a considerable effect on the data interpolation. These effects allow data to be more accurately modeled, including all known boundaries and discontinuities. I'll go into more detail on the difference between these two features and some of the ways they can be used in the next section of the webinar. Any questions so far? Okay. The next topic I'll discuss is how do I define breaklines and faults in Surfer? Breaklines and faults are both defined in Surfer using BLN files. A BLN file is Golden Software's vector file format. It is a simple text format that defines points, polylines, and polygons. Let's take a brief look at an example BLN file in Surfer. You can open and edit BLN files in the Surfer worksheet by clicking File Open, selecting the BLN file, and clicking Open. This BLN file contains three objects: a point, a line, and a polygon. Each object in a BLN file consists of a one-line header row and a list of XY coordinates for each vertex in that object. The header row contains the number of points or vertices in the object in column A, a blanking flag value in column B, and an attribute for the object in column C. For defining breaklines and faults, both the blanking flag and attribute values are optional and can be left out if desired. Following the header row, the coordinates are listed with the X data in column A, the Y data in column B, and for breaklines, the corresponding Z data in column C. Z coordinates are only used in the BLN file when it is used as a breakline file. The Z values are ignored if the BLN file is used as a fault line, for blanking a grid, or for creating a base layer. Object types are differentiated by the number and uniqueness of points. A point is defined by a header row and a single set of coordinates. A polyline defined by a header row and 2 or more unique XY coordinates. A polygon is nearly identical to a polyline, except the first and last coordinates are identical. The repeated coordinates tell Surfer to close the object and define it as a polygon. As you can see in this BLN file, the Z coordinates are present for each XY point, so it could be used to define a breakline or a fault. We'll apply breaklines and faults to a grid in the next section, but before we move on, are there any questions about defining breaklines and faults using a BLN file? If you are unfamiliar with BLN files and would like more information about creating them, we have a number of online resources available. These include a great webinar our Surfer product manager, Carrie, hosted last year, as well as the knowledge base articles, How Can I Create a BLN File? And I Want to Blank Outside Several Polygons on a Map, but the entire map gets blanked, resulting in a horizontal planar grid. Okay, we have one question. What is a blanking flag? We use the term blanking flag to describe the process of assigning a null or no data value to a specific area of a grid. The blanking flag tells the software whether to blank or null data inside or outside a polygon. All right, looks like no more questions. The next topic I'll cover today is how do I apply breaklines and faults to my data when creating a grid. As I mentioned earlier, breaklines and faults are used to provide additional information about the data during gridding. However, not all gridding methods support breaklines or faults. For example, the Kriging gridding method supports breaklines but not faults. This table lays out which gridding methods support each of these features. Let's first grid a data set with the default settings without applying a fault or breakline and create a map from it. I'll click Grid Data, select the data file, and click Open. Kriging is our default gridding method, so I'll select that. And I don't want a grid report, so I'll uncheck that box. And I'll click OK. And the grid is created. Now I'll create a contour map. And I'll add a post layer so that you can see the distribution of the original data points. I'll also add a base layer of the BLN file to be used as a breakline for a reference. I'll change the line to red so it's a little more visible. Okay, now let's walk through applying a breakline to a grid in Surfer. As I said earlier, a breakline is used to define a change in slope or a linear feature with a known z-value. Because breaklines define a feature with a known z-value, all vertices in the BLN file must have an associated z-value. I can verify this by opening the BLN file I'll be using to define the breakline. You can see in this BLN file there is a known z-value in column C for each XY dataset in columns A and B. So now let's grid a dataset using a BLN file as a breakline. Click Grid Data, Select the data file and click Open. Many gridding methods support breaklines, including kriging. I'll leave the method set to kriging and click Advanced Options. Click on the Breaklines tab and add the breakline file. I'll click OK in the Advanced Options dialog, and then OK again in the Grid Data dialog. First, I want to rename this one. And the grid is created. Now I will create a new contour map and I'll add a base layer showing the breakline. As you can see, the top ridge is now more clearly defined, and two of the rivulets on the side of the mountain are also visible on the map. Now I will create a new contour map and add a base layer showing the Now let's walk through applying the same lines as faults to a grid in Surfer. As I said earlier, faults act as barriers to information, and since faults do not use elevation data, the z-values in my BLN file will be ignored. Click Grid Data, select the data file, and click Open. Not all gridding methods support faults, but minimum curvature does, and it produces similar results to the kriging algorithm. I'll select minimum curvature, click Advanced Options, and then click on the Breaklines and Faults tab. I'll add the fault file and click OK. I'll rename this grid as well. And click OK again. Now I'll create a new contour map. Using the fault grid file. The fault information is saved in the grid and automatically displayed on the contour map, as you can see here. The fault line properties can be changed by selecting the contours layer and clicking the General tab in the Property Manager. In the fault line section, the line style, color, opacity, width can each be customized. I'll make my fault line red to match the other two maps. If any post-processing, such as grid math or grid filter, is performed on the grid, the fault information will be removed from the grid file. The fault information can still be displayed as a base map like we did for the breakline, but it will not automatically be included. As you can see, the faults have influenced the resulting contours quite differently than the breakline. The faults work nicely to define the rivulets in the side of the mountain, but the ridge along the top is better defined using a breakline. Are there any questions about applying breaklines and faults or any other parts of this webinar that I haven't already addressed? Okay, we have a question. Whenever I try to use breaklines, I get the error message, insufficient memory to perform operation. Module surfer file UI srfwrnd proc.cp. Insufficient memory errors are something that we cannot really control. If you're getting an insufficient memory error, the first thing I would recommend doing is restarting your computer, because all of our programs require contiguous memory, meaning that if you've opened and closed a lot of programs since your last restart, not all of the memory available on your computer will be available to Surfer. Are there any other questions? Okay. There is not a visible difference between the original grid and the breakline. So we can zoom in, and perhaps you'll be able to see a little better. On the original grid, The ridge of Mount St. Helens is fairly soft, and there's a rivulet here that isn't really defined in this grid file. If we zoom in on the breakline grid, you can see that the ridge of Mount St. Helens is more clearly defined here, and the rivulets here are a little more obvious in the contours. We could also create a 3D surface from this grid if we wanted to really be able to see the difference in elevation values. And I can email you the data with that 3D surface if you'd like. So another question we have is, how do you know the throw on each side of the fault is correct? No z-values were given by the fault. That's correct. All faults in SURFR are considered vertical, so they don't represent geological faults with throw or movement along the fault line. This was discussed earlier on in the webinar, and if you'd like more information, you're welcome to email me at katie@goldensoftware.com. Okay. Another question we have is there anything special we need to know about how the ends of faults work? Well, since faults are considered boundaries to data information, the end of a fault will simply allow SURFR to access all of the data around the end of the fault. So the data interpolation will not cross the line, but once you reach the end, all data at the end of the line will be used during data interpolation. Can one combine both faults and break lines at the same location to simulate a geologic fault? So I'm not sure exactly how that would work. I'd have to look into it. The one primary difficulty with that I can see is that while break lines allow you to assign a z-value, you can't shift the XY data on one side of the line versus the other. But yes, you could apply a fault and then a break line to the same grid to try to simulate the effect. Another question we have, which map best reflects reality? So for Mount St. Helens, I used a fairly coarse data set to grid this area. I think that the break line grid best reflects the ridge of Mount St. Helens, and the fault lines better represent the rivulets in the side. And another question we have is there a particular gridding method that works best with faults, break lines, or does the source data for the contour plot determine this? There isn't really a gridding method that works best with faults or break lines. As shown on this slide, not all gridding methods support both faults and break lines, or either in some cases. The data distribution and values are still going to have a great effect on your gridding results, and the best gridding method for your data is still going to depend on that data distribution more than the fact that you're using faults and break lines. Okay, I think that's it for questions. So that concludes my presentation on break lines and faults and how to use them in SURFR. If you have any additional questions once the webinar is concluded, you can call our technical support phone line at 303-279-1021 or email questions to surfersupport@goldensoftware.com. Again, a recording of this webinar will be posted shortly on our website at www.goldensoftware.com. I also want to let you know that we're running a buy one get one half off special on Surfer for the month of February. If you enter promo code BHWWR at checkout, you will receive 50% off your second Surfer license in your order. Thank you for your time, and I hope you all have a great day.